Hello, and welcome to A Doctor's Diary, practical medicine for everyday clinical life. In this video, we are discussing an important infectious disease that, although rare in many parts of the world, remains clinically relevant because of its severity and potential public health implications. Anthrax. Anthrax is caused by a bacterium called Bacillus anthracis. It is a gram-positive, rod-shaped bacterium capable of forming spores. These spores are extremely resistant to environmental conditions and can survive in soil for decades. When the spores enter a suitable environment, such as the human body, they can transform into active bacterial forms that produce toxins responsible for tissue damage and systemic illness. The virulence of Bacillus anthracis is mainly related to its ability to produce toxins and a protective capsule. These toxins cause local swelling, tissue destruction, and systemic effects that can lead to severe disease. While the active bacterial form can be destroyed relatively easily with standard disinfection methods, the spores are highly resistant to heat, drying, and many chemical agents, making environmental persistence a key feature of this organism. Anthrax is a zoonotic disease, meaning it primarily affects animals, but can be transmitted to humans. The disease is found worldwide, but occurs more frequently in regions where livestock farming is common. Individuals at higher risk include those working with animal products such as hides, wool, bones, or meat, as well as people involved in agriculture, veterinary medicine, or wildlife handling. Humans can become infected through four main routes. The most common form is cutaneous anthrax, which occurs when spores enter the body through small breaks in the skin. Inhalational anthrax develops after inhaling airborne spores. Gastrointestinal anthrax occurs after consuming contaminated meat products. Injection anthrax has been reported in individuals exposed to contaminated injected substances. In general, person-to-person transmission of anthrax is extremely rare. However, in cases of skin involvement, strict hygiene measures are recommended to prevent possible spread. The incubation period varies depending on the route of exposure and the number of spores involved. Cutaneous anthrax typically develops within hours to several days after exposure. Inhalational anthrax usually appears within 4 to 6 days, but may occur much later. Gastrointestinal and injection forms generally develop within 1 to 3 days. Cutaneous anthrax is the most common naturally occurring form of the disease. It typically begins as a painless papule at the site of infection. This lesion progresses into a fluid-filled blister and eventually forms a characteristic ulcer covered by a black scab, often referred to as an eschar. Although the lesion is usually painless, surrounding swelling can be significant. With early antibiotic treatment, cutaneous anthrax is generally manageable and has a favorable prognosis. Inhalational anthrax is the most severe form. Early symptoms resemble a nonspecific viral illness, including fever, fatigue, headache, and muscle pain. However, within a short period, the disease can progress rapidly, leading to severe respiratory distress, circulatory failure, and sepsis. Imaging studies may show widening of the mediastinum, which is considered a classic radiological finding. Because of its rapid progression, early recognition and treatment are critical. Gastrointestinal anthrax develops after ingestion of contaminated food. Early symptoms include abdominal pain, nausea, vomiting, and fever. As the disease progresses, severe inflammation may occur, leading to bloody diarrhea and peritonitis. Advanced disease remains difficult to manage. Injection anthrax is characterized by severe soft tissue infection at the site of injection. It may present with extensive swelling and tissue necrosis. A serious complication that may develop from any form of anthrax is anthrax meningitis. This condition is associated with rapid clinical deterioration. It represents a medical emergency with high mortality if not treated promptly. Diagnosis of anthrax requires microbiological confirmation whenever possible. Samples should ideally be collected before starting antibiotic therapy. Depending on the clinical presentation, specimens may include blood cultures, wound swabs, respiratory samples, stool, or cerebrospinal fluid. Laboratory methods include microscopy, culture, PCR, and serological techniques. In suspected cases, involvement of specialized laboratories is recommended. Treatment depends on the severity and clinical form of the disease. Antibiotic therapy remains the cornerstone of management. In cases of systemic involvement, treatment should be administered intravenously. When the CNS is affected, antibiotics capable of penetrating the CSF are required. Prevention focuses on minimizing exposure to potentially contaminated animal products and maintaining strict hygiene practices. Proper handling of animal materials and awareness of risk factors play an important role. In certain high-risk environments, vaccination may also be considered. Although anthrax is rare in many regions, its potential severity makes awareness essential. Early recognition and treatment are critical in improving outcomes. If you found this explanation helpful, consider following a doctor's diary, where complex medical topics are transformed into clear, practical knowledge. Medicine is learned from books, but real understanding comes from shared experience. Thank you for watching, and I'll see you in the next entry of A Doctor's Diary.